All right, hello and welcome to section 2.5, scatter plots line of best fit. Again, I'm hoping this is a review from much of Algebra 1. Um, so here's a scatter plot, all right? And if you don't remember what it is, it's just a set of points um, between two variables, right? Which oftentimes can be just like x and y, but this is actually something that's used a lot in real life. So many of the quantities today, instead of x and y, are going to be actual real life values. Okay, so in this case, we have height as our x variable and weight as our y variable, right? And so like this dot down here might represent someone being 5 feet tall and say like, I don't know, 100 pounds or something like that. And so the idea is um, to see the relationship between the two variables, right? And that relationship is oftentimes called the correlation, right? And so it's really today the whole point of a scatter plot is how are two variables related. And in this one, we can see not surprisingly, as you get taller, you weigh more, right? In general, think of a little kid that don't weigh much, and then as you grow up, you start to weigh more. And obviously there are exceptions to that, but in general, the pattern is as height goes up, right? As height increases, weight also increases. Okay, so today is scatter plots, and in particular, we're going to talk about the relationship. The whole point of a scatter plot is the relationship between the two variables. Okay, so this idea is called correlation, and this is some notes you might want to get down here. Correlation is just a relationship between the points or the two variables, right? Again, it can normally be x and y, but oftentimes can be real life things. Okay, and so if there's a strong relationship, they'll be close to the line. Okay, so all that means is if we had drawn like a line of best fit, the points will be really close to the line. That's a strong one. A weak one, we can still have like say a positive correlation, but they're farther from the line. And that'd be weak. And then if there is no pattern at all, that's called no correlation. And then the final idea is your correlation can either be positive or negative. Okay, so you have sort of a picture here of no correlation in the middle where there's no relationship. And then on the left, it's negative correlation and strong because the points are close to a line, right? Versus the second example here, no, it's negative correlation, but they're farther from the line. So it's called like weak, or you might even call that one moderate negative correlation. Okay, and then we have on this side, we have weak positive and then strong positive correlation. All right, so again, the whole point of correlation is the relationship between two variables. So just to give you, like make this more concrete, if we think of some examples here, so like if we think of two variables that have no correlation, the one I always think of is, I'm pretty sure if we plotted people's heights and compared it to their IQ, there would be no relationship, right? As you get taller, that has nothing to do with IQ, right? So there'd be no relationship between those two variables. So what I'd like to do is take a minute, pause the video, and see if you can think of two quantities that would have a negative correlation, and then at least one example of two quantities that have a positive correlation. All right, I'm back. Hopefully you've thought of these. So negative correlation, what I always think of, I guess, is cars. And as they start to weigh more, like the weight of your car, that would negatively correlate with the MPG, miles per gallon, right? The bigger, heavier car it is, the less good gas mileage it's going to get. Another pretty famous one from like the world of the economic world is like if you raise the price of something, the number of units that you sell will generally go down, right? So if you have a t-shirt or something, and as you increase the price going this way, that'll make how many you sell generally drop. All right, positive correlations are usually easier to think of. One example might be like how much you study, like how many hours you study for a subject, and then your percent, like your grade percent. So as the hours increase in study, your percent also increases. So they're going up together. This is going up as this is going up. Another one might be just like hours of practice that you practice a sport or something, say soccer, and then how many goals you score. Right? If you're a forward or something, the more you practice, the more goals you score. Generally, I'd be willing to bet that those two, practice and goals, have a positive correlation. Okay, and so I just want to talk about some examples from my life. This is something that I think is actually really fascinating. And so back when I taught 8th grade, I looked a lot like an MCA score, right? So that was actually my Y variable over here is MCA score. I wanted to know what things led to good MCA scores, right? What was positively correlated with doing well on the MCA test? Okay, and this is one you guys might find interesting. Is surprisingly the percentage of homework that my students completed had very little effect on the actual MCA score, right? So what this is graph is showing here is a bunch of points, and this is almost no correlation, right? Meaning homework percentage, the more you do, that really does not change your MCA score. All right, it did have a slight positive correlation. Um, if you look, this number is like called the correlation coefficient and shows you how strong the correlation is. And this one here is pretty weak because this number is small, so it's a weak positive correlation. Also notice that the slope of this line isn't very great, so that means as you do a little bit more homework, like the bottom number would say 1% more in homework, then your actual MCA score does not go up that much, right? So again, this is all telling us that there's not a strong relationship between two variables, and so increasing homework percent really didn't help for how well my students did on the MCA score, right? And I plotted a whole bunch of different things along the x-axis here. The one that I found actually had the best, strongest correlation was their score as a seventh grader. So if I plotted their seventh grader score and then the score they had with me when they were in eighth grade, those were strongly positively correlated, just meaning what they kind of knew coming into class was the best predictor of how they would do in eighth grade. Here's another one. This one is more maybe related to your life, where we've got, say, your phone, okay, and how many hours you've using it and what percent of battery life is remaining. So we took all your phones in this class and how long you've had them on and how much battery is using. We might get a graph like this. So my question is, what type of correlation is this and what does it tell us? Okay, so hope you had a chance to think about it. So this would be negative correlation because there's a negative sloping line going down. And I would say this is like moderate or maybe strong, I guess. You could say that's kind of strong correlation. Just means there's a strong link, and that makes sense, right? The more you use your phone, the less battery it's going to have. There's a strong link between those two things. Okay, one more for you to look at here. This is from my real life again. This is when I worked at 3M. We were working on street signs, and they'd make the street signs, and they had these little angles in there to make the light reflect correctly, and if they worked right, it would be really bright sign. So they had me do how much air there was in their sign. These are degrees of air, and how bright the sign was, which is actually measured in something called candle power. Okay, so again, pause the video here, and what type of correlation is there, and what does it tell us? Okay, so back with you. Hopefully you figured out this is negative again. So it's a downward sloping line. I would say this is definitely strong correlation, which means it has a big effect. So the more air there is in the sign, that greatly affected the brightness of the sign. So that would tell us we really need to focus on making the air as small as possible if you want to get really bright signs. Again, this number you see here is called the correlation coefficient, which just tells you how strongly or how closely they are linked. Okay, I realized I forgot one thing back on our MCA score. This would be positive. I forgot to mention that. This would be positive, slightly positive. I guess you could say no correlation to, and that would be pretty much correct. And then it would be weak, right? I think probably the best answer is positive weak because we do have a line sloping up here. So I'd say positive and weak correlation for you.